Today, we are going to study about the probability. And this is the chapter 2, Introduction to Probability. And this is the chapter outline. And firstly, we are going to study about the sample spaces and events. The sample space is called 표본 공간 in Korean. And in this chapter, we are going to study about the random experiments and sample spaces and events and count technique. And after finishing the chapter first, we are going to study about the interpretations of probability. So how can we interpret the probability? And in this chapter, we are going to study about the axioms of probability. And axioms is called 공리 in Korean. 그러니까 공리가 뭐냐면 어떠한 논리적 체계를 구성할 때 여러 가지 명제들이랑 가정들이 필요한데 그 모든 가정들에 대해서 증명을 할 수가 없기 때문에 몇 가지의 가정은 증명하지 않고 맞다라고 가정하고 그 논리 체계를 구성하는 걸 얘기합니다. 이거는 이 챕터에 가시면 아마 다시 이해가 되실 거고요. And we are going to study about the additional rules and the conditional probability, which is called 조건부 확률 in Korean. And we are going to study about the multiplication rule and the total probability rule or formula, which is called 전확률 공식 in Korean. And after finishing this chapter, we are going to study about the independence and how the probability is affected by the independence will be discussed in this chapter. And after that, we are going to study about the Bayes theorem. And then finally, we are going to study about the random variables. So this is the order of this chapter. And this is the learning objectives for the chapter 2. And after careful study of this chapter, you should be able to do the following. Firstly, you can understand and describe what is the sample space and events for random experiments with graphs, tables, lists, or tree diagrams. And today's class, we are going to discuss about the tree diagrams with considerable detail. And then we can interpret the probabilities and use probabilities of outcomes to calculate the probabilities of events in discrete sample spaces. And for the sample spaces, there are two options, two cases. First one is the discrete case. And this case, the sample space only includes the countable number. And we also have the continuous case for the sample space. In this case, we can have the sample space with interval. So this can be explained in the later section today. And we can use the permutation and combinations to count the number of outcomes in both an event and the sample space. The permutation is 순열 in Korean. And this is the brief explanation for the permutation. If we assume that there are three items called X, Y, Z, the permutation of these items will be X, Y, Z, X, Z, Y, Y, X, Z, Y, Z, X, Z, X, Y, and Z, Y, X. So this is the permutation of these three items. And then we can also calculate the probabilities of joint event, such as unions, which is called 합집합 in Korean, and the intersection, which is called 교집합 in Korean, from the probabilities of individual events. And after that, we can interpret and calculate the conditional probabilities of events. And after that, we can determine the independence of event and use independence to calculate the probabilities. And after finish this chapter, we are going to study about the Bayes theorem. And we can use the Bayes theorem to calculate the conditional probabilities. And finally, we can understand what is the random variables. And this will be discussed at the end of this class, at the end of this chapter. And firstly, we are going to study about the random experiment. And the goal of random experiment is to understand, quantify, and model the variations affecting a physical system's behavior. And the model is normally used to analyze and predict the physical system's behavior when the system inputs affect the system outputs. The predictions normally are verified throughout experimentation with the physical system. And this is the typical description for the relationship between the physical system and the model. Firstly, we can perform the experiment based on the physical system, and then we can obtain the result or data from the experiment. And based on the measurement, such as data or conclusion, we can propose a model. For example, based on the regression analysis, as I mentioned in the last class. And based on the proposed model, we can predict or presume the conclusions from the physical system. But if the result from the physical system is not well predicted by the proposed model, we have to perform more experiments to obtain more data. And after perform more experiments, we can gather more data. And based on that data from the additional experiment, we can refine the model. And based on the refined model, we can repredict or presume the physical system. And if the result from the physical system is well predicted by the refined model, we can conclude that the model is appropriate for this physical system. So this procedure is required to have the multiple iterations to obtain the appropriate model for a certain physical system. But normally noises produce output variation. And noise variables cannot be controlled and cause the random variation in the output. So even though we hold the input constant, it does not keep the output constant. So this is the schematic description for explaining about the noise variation. And this is the system, and this is the input. If we provide input into the we probably obtain the output from this system. And there are two variables regarding the system. First one is the controlled variables. And we can simply predict and presume what is the variables for these controlled variables. But there is always unknown noise variables as well in the system. And due to the noise variables, even though we provide the constant input to the system, the output will be varied or changed, which means that we cannot obtain the constant output due to the noise variables. So we have to take into account these noise variables based on the probability. And this is the definition of the random experiment. The random experiment is an operation or procedure carried out under controlled conditions and executed to discover an unknown result or to illustrate a known law. Normally, before starting the experiment, we don't know about the conclusions or result from the experiment. For example, if we know about the result from the experiment, we don't have to do the experiment because we can simply predict the result. So in most cases, we cannot predict the conclusions from the experiment before performing the experiment. So normally we can provide the word random, in front of the experiment because we don't know about the conclusions. And the experiment, the random experiment, can result in different outcomes as I mentioned previously, even though it is repeated in the same manner every time because of so even though we provide the same experimental procedure or same system, the result, the outcomes can be changed every time because of the unknown noise variables. So the randomness normally affects the natural law. And this is the typical example. And in the Ohm's law, current is a linear function of the voltage. The current equals to the voltage divided by resistance. So the current has a linear relationship with the voltage. However, the current will vary due to the unknown noise variables such as the ambient temperature and the contact condition between the device and the electric wire and the size of the electric wire and the relative humidity and etc. There are so many noise variables affecting the current. So the current will vary due to noise variables even though it is under the constant voltage, which means that if we provide the constant value for the voltage, the current can be changed by several factors. So this is the typical relationship between the current and voltage. And the circle indicates the experimental result, and the line indicates the predictive values from this equation. And as you can see here, the experimental results are well predicted by this equation, right? But if you enlarge this part, there is always a discrepancy between the experimental data and the predictive values due to the unknown noise variables. So we have to consider about the noise variables by using some constant or some equations. So in this case, we normally provide the epsilon for taking into account the unknown noise variables. So, and also, the randomness can disrupt a system. And this is the typical example. And telephone systems must have sufficient capacity, the number of lines, to handle a random number of callers at a random point in time whose calls are of a random duration, which means that we have to prevent the blocked call when the random number of calls arrived with a random duration. So this is the example. If calls arrive exactly every 5 minutes and maintain for exactly 5 minutes, only one line is required. Why? If we assume that the x-axis is time in minutes, we can assume that this point where the first call arrived, And we can simply say this is the 0 point here. And the first core will maintain 5 minutes. This is the 5 minutes here. And the second core will arrive at the point immediately after finishing the first core, right? Here. This is the point where the second core will be arrived. Okay? And the second core will also maintain 5 minutes. This will be 10. And this is the point where the third core will be arrived. So, this procedure will be repeated. So in that case, the core did not disrupt by the previous core, right? Because there is no duplication point between the duration of the previous core on the next core. So in this case, we just need to have the first line. But practically, times between cores are random. And the core duration are also random. So in this case, it's not enough to prevent the blocked core. So, but if the number of lines increases, the cost also increases. So the comparative cost is required. This means that we have to find the optimum number of lines that prevent the blocked core, also minimize the cost for fabricating the line. So this can be done by the probability. So this is the conclusions. The telephone system design must include provision considering the input variation. And this is the typical description for differentiating the deterministic system. This is the deterministic system. And this is the random system. And in the top system, the cores arrive every 5 minutes, and core durations are all of 5 minutes exactly. So in this case, we just need to have just first line, just one line. But in the bottom system, the cores are arrived every 5 minutes here, and with the previous case, but the duration is different, even though the duration of the core have the average value of 5 minutes. For example, in this case, the duration of the first call is 2.5 minutes, right here. And the duration of the second call is 7.5 minutes. So if we have the average value for these two values, we can simply have the 5 minutes. This is the average duration for the second system. But as you can see here, there is no problem for the second core because the first core was already finished. So you can have the second core. But in the case of the third core will be blocked by the preceding second core because the duration of the second core is exceeding the 5 minutes. So in that case, the one line is not enough to prevent the blocked core. So in this case, we have to increase the line. But as I mentioned previously, if we increase the number of lines, the cost is also increases. So we have to find what is the optimum number of lines to minimize the cost and to prevent the blocked core based on the probability. And now we are going to talk about the sample spaces the random experiments have unique outcomes, and the set of all possible outcomes of a random experiment is called the sample space, and it is also expressed by the capital S here. And the sample space can be divided into two cases. First one is the discrete case, and this case consists of a finite or countable infinite set of outcomes. So you can count the items included in this sample space. That is the definition of the discrete sample space. And the sample space is also be the continuous system, which includes or contains an interval, either a finite or infinite width of a real number. In this case, we cannot count the number of items included in the sample space. And this is the typical example for defining the sample spaces. If we consider the randomly selected and measured the thickness of a part in material, the sample space of this case will be plus value. Why? There is no minus thickness in real situation. The thickness of some material is always plus value, right? So normally the plus value can be expressed by this I plus symbol, and we can also express this as this equation by assuming that the x indicates the thickness of a material. So the thickness of material always larger than 0, right? There is no 0 thickness in real situation. The thickness is always larger than 0. So this is the continuous system, right? The item is expressed by the interval larger than 0. So we cannot count the number of items included in this sample space. So this is the continuous system. And also, if we assume that it is known that the thickness is between 10 and 11 millimeters, then the sample space will be the thickness is between 10 and 11 millimeters. So this is the sample space for the second case. In this case, also the x indicates the thickness of the material. This is also the continuous system, right? And this is the third example. It is known that the thickness has only 3 values. For example, low thickness or medium thickness or large thickness. This can be. We can have the sample space as follows. The sample space will be so in this case, we can count the number of items included in this sample space, right? This sample space has 3 items, small, medium, large. So this can be the discrete system. And this is the final question. Thickness with the manufacturing specifications. We have two answers, yes or no, right? Yes indicates the thickness does meet the manufacturing specifications. And no indicates the thickness does not meet the manufacturing specifications, right? So we have only two answers, yes or no. In that case, sample space will be, if we express yes to y, no to n, the sample space will be y and n, right? There are two items included in the sample space. So this is also discrete system. And now we are considering two sample spaces, two parts. And in the previous slide, we just consider one part, right? We consider the thickness of one part in material. In this case, we are going to considering about the two part, the thickness from two parts. And if the objective is to two parts meet the specifications, the sample space will be as follows. And there is a possibility that we can select the first part with satisfaction from the specification, right? In this case, the part that we selected meets the specification. And in that case, we can say y here, yes. And there is also the possibility that the second part selected from the experimenter meet the specification. This is also y here. So this indicates that we select two parts, and both parts do meet the specifications. So in this case, we can simply express this case as yy, okay? And there is also a possibility that we can select the first part which meets the specification. We can say y. The second part does not meet the specification. We can say n, right? And there is also the possibility that the first part does not meet the specification, and the second part meets the specification. And there is also possibility that both two parts did not meet the specification. So in that case, we can say NN. So this is the sample space for this question, right? So as you can see, this is also discrete system. And what is the number of conforming parts? The conforming part indicates the part which meets the specification. 그러니까 이 스페시피케이션에 일치하는 부분의 개수를 찾는 거예요. So for this case, we have the sample space as there is a possibility that no part meet the specification, right? In this case, what is the number of conforming part? Is 0, right? No part, there is no part meeting the specification. And there is also the possibility that we can select one part which meets the specification. In this case, what is the number of the conforming part? That is 1. Only one part meets the specification. And also, there is the possibility that two parts are all meet the specification. In that case, the number of conforming parts will be 2. Okay? So this is the sample space for this question. And this is also discrete system. We can count the number of items included in the sample space. Okay? This is the number of the conforming part. So, in the case that the parts are randomly selected until a non-conforming part is found, the sample space will be as follows. There is a possibility that we can select the non-conforming part at the first step, right? At the first time. We select the part, and the part is non-conforming part. In that case, we can simply say N, okay? And there is also a possibility that we can select the conforming part at the first time, and also we can select the non-conforming part at the second time, right? And also, there is a chance that we can select the conforming part at the first time and the second time, and we select the non-conforming part at the third time. And this can be repeated. So, do you think that is the discrete system or continuous system? This is the discrete system. You can count the number of items included in the sample space, but the number of items is infinite. So as I mentioned in previous slide, in the case of the discrete system, the countable infinite items can be also included in the discrete system. So this is also discrete system, but countable infinite. Now, we are going to study about the effect of replacement. And if the batch consists of 3 items, for example, we can simply express the 3 items as A, B, C, okay? And we can select 2 items among these 3 items without replacement. And the sample space can be as follows. Firstly, we can have the A, B, right? In this case, we can select the A item at the first time, and we can select the B item at the second time, okay? And also we have AC here. We can select the A item at the first time, and also we can select the C item at the second time. But we cannot select the A item at the second time when we select the A item at the first time. Why? Because the A item is not replaced into the batch. So in that case, we have 2 options when we select the A item at the first time. And also we can select the B item at the first time, right? And this can be BA or BC. And BB cannot be included in this sample space because there is no replacement. And in the case of C, in the case that we select the C item at the first time, there are also 2 items. So this is the sample space for the first case, okay? And this is also discrete system. And if it performs with replacement, and in that case, the sample space will be changed. We can replace the item after selection, okay? So we can have right? in the case that we select the A item at the first time, we can have these three choices. First one is that we can select the A item again at the second time. And we can select the B item, also C item at the second time. And what about in the case that we select the B item at the first time? That will be BA, BB, BC, right? And in the case that we select the C item at the first time, the items will be as follows. So this is the sample space for the second case with replacement. And based on these sample spaces, we can simply draw the conclusions. And if we assume that this is the sample space of the case with replacement. And what about the sample space for the case without replacement? That will be included in this part. So the sample space of the case without replacement can be included in the sample space for the case with replacement. So this is the subset, which is called 부분집합. So we can, based on these two examples, we can simply draw this conclusion. So with replacement, we can have more choices to select to have the sample space, the number of items included in the sample space. And this is another example to define that the sample space is expressed by a tree diagram. And the messages are classified as on messages, which means that there are 8 outcomes in the sample space. Why? Because we have two classes. First one is that on time, and the other one is late. And we also have 3 messages, and this can be 3 inputs. So based on my previous lecture, if we have 2 levels and 3 inputs, the number of outcomes will be the third power of 2, right? So this is the number of messages, and this is the class. And the message is classified by on time or late. So the number of outcomes will be 8. If we classify the messages from 1, 2, 3, we can firstly think that in the case of the message 1, we can have 2 options. First one is that the message 1 is arrived on time, right? And the other one is that the message 1 is arrived late. And in the case that the message 1 is arrived on time, we have 2 more options for the message 2, which are on time and late. And also, in the case that the message 1 is arrived late, we have the same 2 options. For that, the message 2 is arrived on time or late. Okay? So for the case of the message 3, if we assume that the message 1 is arrived on time and the message 2 is arrived on time, now we have two options that the message 3 is arrived on time or late. And this can be applied for all these points, right? This is the on time, this is the late. And this is on time, this is late. And this is on time, and this is late, right? So finally, total number of outcomes will be 1, 2, 3, 4, 5, 6, 7. Right? So you can obtain the total number of outcomes based on this tree diagram. And this is called the tree diagram, okay? New cars can be equipped with the selected options as follows. First one, the manual or automatic transmission. The second one, with or without air conditioning system. The third one is we have three choices of stereo sound systems. And also we have 4 exterior color choices. In that case, what is the total number of outcomes from this case? And we can also simply obtain the total number of outcomes based on the tree diagram. And firstly, we are going to start with the transmission. We have two types of the transmission. First one is the manual transmission, and the second one is the automatic transmission. And in the case that we have the manual transmission, we have two options that we can have the air conditioning system or not. So we can have the air conditioning system or not. And in the case that we have the automatic transmission system, we also have the same tree here. We can have the air conditioning system or not. And in the case of the stereotypes, we have 3 options, right? If we express the 3 types as 1, 2, 3, we can have the 3 trees below the air conditioning system, right? Which means that in the case that we have the manual transmission system with the air conditioning system, we have 3 options to have the stereotypes, right? One, two, three. And these 3 can be here, 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 right? And after that, we have also the options for selecting the exterior color. And based on this question, we have 4 options, right? That means at each point here, we have 4 branches, right? We can apply the 4 branches for every point. So we can simply obtain the total number of outcomes based on this tree diagram. And based on this diagram, this tree diagram, we can also increase one more option, which is that of the interior color, black, blue, brown, is added. And it depends on the exterior color as follows. With a red exterior, only a black and red exterior can be chosen. And with a white exterior, any interior color can be chosen. We can choose 4 different colors for interior. And with a blue exterior, only a black, red, or blue interior can be chosen. And with a brown exterior, only a brown exterior can be chosen. And in the case, first we have to think about the possibilities before selecting the exterior color, right? Because based on each color of the exterior, we have several options for selecting the interior color. So before selecting the exterior color, there are 12 possibilities, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In the case of the red exterior color, we have 2 options, right? The first one is the black, and the second one is lead. In this case, what is the number of the total outcomes? We have 12 possibilities before selecting the exterior. And we also have the 2 options for selecting interior based on the exterior. So the total number of outcomes will be 12 multiplied by 2. Okay? So this will be 24. What about the case of the white exterior? We have 4 options for selecting the interior color, such as red, black, blue, brown. In that case, the number of total outcomes will be 12 multiplied by 4. Okay? And this will be 48. And in the case of the blue exterior color here, we have 3 options for selecting the interior color, including black, red, blue. In this case, the total number of outcomes will be 12 multiplied by 3, 36. And finally, in the case of the brown exterior, we have only one option, that we can select only brown interior color, right? So 12 multiplied by 1 equals 12. So what is the total number of outcomes for this case will be the summation of 24, 48, 36, 12. So that will be 120, okay? So sometimes the tree diagram is very complex to obtain the final number of outcomes. But in this case, this is very useful to calculate this very complex type, right? This very complex case. So based on the complexity, we are using this tree diagram. Sometimes the tree is very effective to draw the exact conclusion, okay? And events are set of outcomes. The event is a subset, 부분집합, of the sample space of a random experiment, such as one or more outcomes of the sample space will be the event. 그러니까 이벤트가 그 샘플 스페이스의 하나의 부분이라고 보시면 돼요. 부분 집합. So the event combinations are, first one is the union, which is called 합집합. And union of two events is the event consisting of all outcomes that are contained in either of two items. So the union of the event E1, E2 can be expressed this symbol, the union of E1 and E2. And this is also called E1 or E2, okay? And this is the intersection, which is called 교집합. And the intersection of two events is the event consisting of all outcomes that contained in both of two items, two events. And this can be expressed by this equation. This is the intersection of E1 and E2. And this is called E1 and E2. So the union is or, and intersection is and. And the last one is the complement, which is called 여집합. And the complement of an event is so in this case, we can simply express by E prime or denote as EC. C. And recall the sample space from the previous example, 2-2. The sample space include YY, YN, NY, YY. And this is concerning the conformance to specifications. And Y indicates that the part meet the specification, yes, right? And N indicates the part does not meet the specification, which is no, based on the previous slide. And let E1 denote the event that at least one part does conform to specification. So the event of E1 will be Y, 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 N, N, Y, right? Because based on this sentence, the E1 only have the part with at least, because based on this sentence, the E1 denotes the event that at least one part does conform to the specification. 그러니까 Y가 하나도 포함된 걸 포함하라는 얘기잖아요, 그죠? And let E2 denote the event that no part conforms to specification. So the event of E2 will be N, right? And E3 denote the null or empty set. So the event of E3 will be null, okay? And let E4 denote the universal set, which means that the event of E4 equals to total sample space. Let E5, for the case that at least one part does not. So the E5, the event of V5 will be YN, N, Y, N, right? 그러니까 스페시피케이션을 일치하고 있지 않는 하나의 파트를 반드시 포함하는 집합이니까 YY는 빠져야겠죠. So based on these 5 events, we have to calculate the union of E and E5. So the union of E1 and E5 will be YY, YN, N, Y, Y, N, N, Y, N, N. But as you can see here, this part is duplicate with the previous one, right? So we have to delete these things. Then finally we can have the event as follows: y, 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 n, n, y, n, n. And this is the total sample space, right? And what is the intersection of E1 and E5? That is y and y, right? And what is the complement of E1? There will be n, right? The complement of E1. So this example is for considering the discrete event only. Okay? And now we are going to considering about the continuous event. The continuous includes the interval. Okay? So the measurement of the thickness of a part are modeled with the sample space S equal to R plus. And this can be expressed by this equation. Right? I explained this part at the beginning of today's class. And let E1 indicate the thickness is between 10 to 12 millimeters. And let E2 indicate the case of that the thickness of a part is between the 11 and 15 millimeters. Then, what is the union of E1 and E2? The union of E1 and E2 will be the thickness between 10 to 15 millimeters, right? And what is the intersection of the E1 and E2? There will be the case with the thickness between 11 to 12. Okay? And what is the complement of E1? That is the X will be smaller than 10 millimeters, right? And also should be larger than 15 millimeters. Okay? But in that case, sometimes we have to provide this symbol because the thickness always should be larger than 0, right? But as we already defined the sample space of the thickness, you don't have to provide this part here, okay? 어차피 저희가 다 알잖아요. 두께는 마이너스 갈 수 없다는 걸 알고 샘플 스페이스를 이미 플러스 범위로 정의를 하고 있기 때문에 원래 이렇게 들어가줘야 되는 건데 이거를 안 써도 된다고요. 문제에 이미 정의가 되어 있기 때문에. 아시겠죠? So, what is the intersection of complement of E1 and E2? That is 아, 12죠, 12. 그럼 그렇죠. So the intersection of the complement of E1 and E2 will be this, okay?